Hello, this is Steve Hartley, G0FUW, and I'm here with Dan, M0TGN, and Lewis, G4YTN. And we're going to do a short demonstration on inductors. So now we can switch over to measure some inductors. So if we go into inductance mode on the analyzer, and we're going to start out with this small coil. It's made with enamelled copper wire and quite a small diameter, and we'll just clip him onto the terminals and see what sort of value this one comes up at. There we go. What's that reading, Dan?
It's 0.396.
Okay, so less than half a microhenry, but it is a very small coil, the sort of thing you might see in a VHF kit. So if we take that one off, now we've got a coil here that's got the same number of turns and it's about the same length, but clearly it's a much bigger diameter. And there are no formula in syllabus for coils and windings, but you are expected to know that more turns gives more inductance and a larger diameter gives more inductance. So we've got the same number of turns, but we've got a much bigger diameter. So we've gone from less than half a microhenry to
5.75.
5.75, which is more of a sort of a HF kind of value that you might find in an antenna trap or something like that. We'll change to another one, and it's made the same diameter, but as you can see there's many more turns, probably about twice as many turns on this one. So more turns but the same diameter. We'd expect this to be larger again.
That's 27, 28, wait for it to settle down. 27 microhenries there.
Okay, so yeah, it's varying around a little bit, but it's around about that sort of value. Perhaps if we change the frequency a little bit, well that steadies it down a little bit. It's about 27 microhenries. So again, the theory adds up. The longer the coil, the more turns, the bigger the diameter gives more inductance. We'll try the series connection again, as we did with the capacitors. If we connect the two coils together, what we're effectively doing is putting even more turns on the coil when we put them in series. So we had 26 and 5, you add them together, it comes up to
just under 35, so 34.95.
So they're adding together, we're getting more inductance with the connected in series. It's unusual for inductors to be used in parallel, but if we do connect them in parallel, what we should find is that the two act a bit like resistors in parallel, and we end up with something that's smaller than the smaller of the two. It's refusing to clip on there. Okay.
That's 4.56 microhenries.
Again, so we've shown that the theory works. As I say, it's very unusual to have inductors in parallel in real life, but if you do connect them in parallel, you end up with a smaller value than the smaller of the two.